Hi! Today I wanted to show you how you can create the kind of mirroring effect you see on screen right now. So let's go. To start out with, we have a fairly simple player script. All it really does is move around. Pressing buttons doesn't actually do anything much. All I can do is move here. Then we have some static body colliders here. The first one is the big collider here that's made out of a few collision polygons, just to make sure I have something to collide with. And further, I have some mirrors, which have two collision layers actually, and are named as mirrors in the group section. That way they are easy to recognize later. Now these are on the player collision layer, so the one that collides with the kinematic body 2D, and another one that's going to collide with a raycast node, which specifically checks if it's colliding with anything that should interact with the light, which could be separate from the player movement. So let's get into the code. First of all, we are going to want to have a process. That's where pretty much all of the magic is going to happen. First of all, let us create two variables. We want our raycast 2D, which is right here, and our line 2D, which is right here in the body, to be saved in variables for easy access. Next, since our line works like this, let me just show you quick. We create a bunch of points and they are added to a list like that. So we want to make sure that at the start of each process frame, this is empty. So what we can just do is line.clear points, and we won't have to worry about anything. Now, with that being empty, it's time to check for input. So whenever input.is mouse button pressed button left, so whenever the left mouse button is currently down, we want to add another point. So the first point is just add vector 2.0. The reason for that is that the line has relative coordinates. So the coordinates are relative to the origin of the line, which is right at the tip of our staff. As such, the first point should be at position 0. Now, from there, we want to go into a first raycast. So we want to see what our line might be colliding with. So what we can do here is just say the ray's global position is set to whatever the global position of the line is, because that's our initial position. We want our ray to start right there at the tip of our staff as well. Then the position we cast to, that's relative coordinates again, should be global mouse position minus our start position. Then we normalize it, so we remove the length of this, so because we don't actually care how long this length here is, we just want the direction. And then we multiply it by 1000 to have a maximum length of how far our raycast can travel in that direction. Lastly, we need to update it, because if we don't force a raycast update here, it's not going to change the position of the raycast and its length until the next physics frame. So we just do it manually. Now we're going to want a while loop here, because this while loop allows us to reflect off a mirror and then basically do the same thing again. We start another cycle, we check it, do a raycast, and then we maybe hit another mirror. So we start another cycle, we do another raycast, and we see if that hits the mirror. And so on and so on. So first of all, we want to see, are we colliding with anything at all? So let's add that part. So if we aren't colliding, then we want to get out of the loop as soon as possible. But we need to check where we are colliding, because we want to add our endpoint where we are not colliding, but the end of our line. We all want to add that as another point to our line, so it's actually visible and doesn't just disappear. So we calculate that from the global position plus the cast to. So we have the endpoint, and since that is in global coordinates, we need to use line.toLocal to transform it into local coordinates. That way it's fitting for the way line works again. The same as before with the vector 2.0. Next, we want to say that we actually get some information about our collision. So now that we're actually sure that we are colliding, we can say get collider and get collision point. Both of these are available now and will be quite helpful, because now we can check if our collider is indeed a mirror. Anyway, we know our collision point, so we can say line.addPoint, line.toLocal, again change from global to local coordinates, and add our point in here, which we just got from our raycast. So we increase our line all the way to the next collision point. Now, after this, we want to check, is it a mirror? So if it's not a mirror, we want to leave the loop here because we don't reflect. So there's nothing to loop over. If not collider is in group, mirrors, break. Seems fine, it's not complaining. So yeah, at this point we can be sure that we are colliding with a mirror indeed. So now we want to see what angle are we colliding at. To do that, we can just use the collision normal. The normal is essentially a vector that is perpendicular to whatever surface we are colliding with, so we can use that to calculate how we should bounce off it. So our normal is ray.getCollisionNormal. There's one bad case we're gonna filter out, which is if the normal is equal to the 0 vector. This can happen if our collider starts out inside of a hitbox or something like that. So just in case that ever happens, we break and just stop. That way it can't cause any issues. So that should be fine. At this point, we're essentially gonna do the same thing we did at the start before, and we can say our ray global position gets updated to our collision point. So our new raycast, we're starting a new one, is starting where the old one ended at the collision point. The new cast position is just the old cast position, bounced, which is a vector2 function that's very convenient for our case, of the normal. So we are going in, we are reflecting of the normal essentially, and bouncing back. And that's pretty much most of the code done. Now there is one issue, and the issue is with our point. Our point is already inside of a collider, and if we were to just continue now, it would actually cause some issues. First of all, let's see. Of course, I didn't declare that as a function. Yeah. Alright, yes. So here the issue we currently have is that we're colliding with this thing, but we're almost always gonna be inside of the collider. So most of the time it's not actually reflecting, but it's just stopping there. Now to fix that, what we want to do is we want to disable the collider for just a little bit. So essentially, after we do this check for the normals here, we're just including a little bit more code to update the collisions. And before here, let's just define our variable. So previous equals null at first. So that's always going to be our previous collider. At the start there isn't one. But later, when there is one, we basically can check if previous doesn't equal null. Then we want to set our collider back to default. We already checked that earlier. Our collider is bits 0 and 1 basically, which is equivalent to saying that our layers are 3. So we can say pref.collision mask equals 3, pref.collision layer equals 3, and that should be fine. That's how we can reset it to normal. But in this point here, we want to update previous now. So we say previous is now equal to our collider here we just collided with. Because this allows us again to disable the collider just until we get back here in the loop to re-enable it. So we can say previous.collision mask equals 0, previous.collision layer equals 0, and disable it right here. Now that almost works fine, but we need to account for this thing staying disabled at the end of our loop. So once we get out of this loop, we just gotta get in here and re-enable it one more time. Just the last previous one we get should be reset here, the very last collider. And now everything works fine. At this point, there's only one issue you really want to be careful with. Because currently, if we align two mirrors to be parallel to each other, we can cause an infinite loop where it just keeps bouncing back and forth until your computer runs out of memory, or your operating system stops it to crash. Now, to prevent that, there's a pretty easy fix, because we can just go and say we set a maximum number of bounces. So we say bounces equals 0, we want to count those. We say up here, var max bounces equals, let's say 5, for example. And if we have a bounce, where is it? It's right here. So in this case, we just bounced, so bounces plus equals 1. If bounces greater equals max bounces, we break. So we can just leave the loop if we ever get too many bounces. So let's just test that quick. 0. Nope. 90. Move it here. Make a duplicate. Move that here. Actually, move it here. There we go. Now these would cause an infinite loop, but as you can see, after 5 bounces it's just gonna stop and finish there. And with that, this should run without any major issues. That will be all for today. Bye!